So today we are going to see another topic, Cauchys theorem. This is one of the topic in the module 3. Statement of the theorem is if first condition f of x and g of x are two continuous functions on a closed interval a comma b, and second condition f of x and g of x are two differentiable functions on open interval a comma b, then there exists a point c between the open interval a comma b such that f of b minus f of a by g of b minus g of a equal to f dash c by g dash c. In the previous mean values theorem, Lagrange's mean value theorem or Rolle's theorem, we use the only one function. Now in the Cauchys mean value theorem, we use the two functions. F of x and g of x are two continuous functions on the closed interval a comma b, and both are differentiable on the open interval, just like in the Lagrange's mean value theorem. Then there exists a point C lies between A and B. Open interval means C not equal to A as well as C not equal to B. It is not equal to the boundary point, such that in the numerator f of b minus f of a by denominator g of b minus g of a in the left hand side. Right hand side value is f dash c. Dash means derivative. Derivative of f at point C by derivative of function g at C. At C means first find the derivative, later we substitute x value with C. Now we are going to see a problem based on the Cauchys mean value theorem problem. Verify Cauchys mean value theorem for the functions, not function, because we require two functions. For the functions e power x, one of the function, and another function is e power minus x in the interval, closed interval a comma b. In the closed interval a comma b. Now we are going to show the verification. Okay. Proof. Or answer. Not good. We use the proof word, because if it is a theorem, generally we use proof. It is a problem, we usually call it as a answer or solution. So answer or solution. So here we have two functions. Let give a names for the functions. Take e of x as a f of x, or give the name for e of x equal to f of x, and give the name g of x for the function e power minus x. Exponential functions are always continuous functions as well as differentiable. We know that first condition verification. The first condition of the Taylor's Cauchys theorem is are continuous functions. We know that exponential functions are continuous. Exponential functions are continuous on total real line. Therefore, in the subpart also, interval nothing but a subpart of the, therefore, these two functions are therefore these two functions are f of x and g of x are continuous on the subpart of the real line. Interval nothing but a subpart of the real line. In the real line, usually minus infinity to plus infinity. This is the real line. Interval is a sum part. So total at all points the functions are continuous. Therefore, in between the points a comma b, also the function is continuous. So next, continuity, first condition over. verification. Second condition. Also we know that exponential functions are differentiable. Exponential functions are differentiable on R. Therefore, f of x and g of x are differentiable in the interval, open interval, in the total R, the functions are differentiable. Therefore, in the subpart also, the functions are differentiable. Therefore, these two functions are differentiable in this subportion. Next, two conditions are C. First condition is continuous. Both are continuous. Second condition is both are differentiable. These two are over. Now we are going to show the other conclusion part. Conclusion part means find C in between a comma b such that this point satisfies these conditions. Next, by Cauchys mean value theorem, mean value theorem, there exists a point C in between a comma b such that f of b minus f of a by g of b minus g of a equal to f dash a, f dash c by g dash c. What about f of b value? F of x value is e power x. F of x value is e power x c. F of x value is e power x. Therefore, f of b means e power b. F of a means e power a. G of x means e power minus x. G of b means e power minus b. G of a means e power minus a. So in the left hand side, that implies the left hand side value of the above expression is e power b minus e power a by e power minus b minus e power a, which is equal to derivative of e power x is e power x itself. So its c value is e power minus c. E power minus x, e power x derivative equal to e power x. E power minus x derivative is minus e power minus x. So therefore, this derivative, this is nothing but g of x. We required g dash of c. Put x equal to c in the derivative value minus e power minus c. Simplify this expression and find c value in terms of a comma b. Carefully observe that in the denominator we written as we have a negative exponent. Send to the denominator, it becomes positive 1 by e power b. The second term e power minus a written as 1 by e power a. We converted into positive terms. Here minus a by minus b nothing but minus a by b. E power c into denominator factor move to numerator, its sign becomes changes. In the denominator e power minus c is there, it moves to numerator, it becomes e power plus c. E power b minus e power a by, take an LCM in the denominator factors. Take an LCM in these factors. We get e power a, e power b by e power b into e power a, which is equal to e power minus e power. Bases are equal, powers are added. Both have same basis, e power c into e power c. So that implies e power b minus e power a by, here take a minus sign common, e power b minus e power a by denominator bases are equal, powers are added. A plus b or b plus a, both are same, minus e power 2c. These factors both are cancelled. That implies minus of e power a plus b equal to minus of e power 2c. Minus minus get cancelled. Finally, we get e power a plus b equal to e power c. Bases are equal, therefore their exponents should be equal. A plus b must be equal to c. That implies C value equal to A plus B by 2. That means average of these two. This is small video regarding Cauchys theorem. Most of the time, important concept is Lagrange's. Comparing with Cauchys, Lagrange's mean value theorem is most important. So here I covered only one problem. No problem. It's enough. In the same pattern, you can find anything.